Okay, last new rule for working with exponents. We are going to make some adjustments to the things that we've learned about these rules as we go along through the rest of the chapter. But for now, let's cover 11.4, and this is the last idea we want to cover. So it's in 11.4, I can raise monomials to a power and simplify using the power rule. So we've learned the product rule and the quotient rule. We've talked about negative exponents and zero for an exponent. Now we're going to talk about the power rule. So again, just a couple warm-up problems right here. It says simplify using the rules for exponents we have learned so far. Base is 2 raised to the 11th, base is 2 raised to the 14th. So the quick way to do this is the product rule. We could add the exponents, or we can just think, hey, there's 11 of them here and 14 of them there, so that means there's 25 altogether here. This is a gigantic number. If we were to type that into the calculator, it's absolutely huge. So I'm going to do that right now. So I've got that in here, and we're going to hit enter, and look at that. Let's see, 33,554,432. So gigantic, definitely not worth writing out. We're just going to leave that in exponential form like we have the other ones so far. Let's take a look at the coefficients here. When we multiply the negative 5 times the 5, we're going to end up with negative 25. I've got 5 m's here and another 5 m's there. So again, adding the exponents, we get m to the 10th. All right, this one right here, we've got a negative in the exponent. Negative means reciprocal, so we're going to do 1 over y to the 6th. Remember, 1 is part of any multiplication or division problem, not going to change the answer at all. And then this one right here, the first thing we notice is we've got z to the 0, so that's just a 1. And then we've got negative 24 for the numbers. We've got x to the 5th, that's going to go on the top, and then the y to the negative 7. The negative means reciprocal, so that's going to go on the bottom. So we've got a y to the 7th on the bottom. Again, the sign changes as we move from top to bottom because that's what it means. It means reciprocal. And then right here, the first thing we notice is we've got an x to the negative 6. There are no other x's here, so that's going to be an x to the 6th on the bottom. And then we've got 3 y's on the top, 4 on the bottom. That means these 3 will cancel with 3 of those. That would mean there's only 1 left, and it's left on the bottom. So we write it like that. And then, of course, there's the 1 left, just like we mentioned up above. And take a look at the next one. Don't let this sneak up on you. First of all, we can take care of the coefficients here. 3 goes in there 5 times, so I've basically cross-canceled here. So I've got a 5 left on the top. And then let's run through and take a look. These are all x's on the top and on the bottom. So let's figure out how many we've got on the top. I've got 10 here and 3 there, so that's x to the 13th. I've got, let's see, 6 here and 8 there, so that's x to the 14th. Still not done because we've got some that have the same base. So if I've got a base of x on the top and a base of x on the bottom, let's see what we've got here. I've got 13 on the top, 14 on the bottom. 13 of them cancel with 13 of these, and then there's just 1 left. So this would be 5 over x right here. So we'll circle that, and we're all finished with that one. Now, if you've been paying attention and looking through this, I am hoping that you've noticed a pattern so far. When we multiply expressions with the same base, we add the exponents. When we divide expressions with the same base, we subtract the exponents. Okay, and depending on your technique, you might subtract the bottom from top or top to bottom, depending on which one has more. Okay, and think about the operations that we use in math. So here's what you learned how to do in elementary school. You first learn how to add, then you learn how to subtract, then you learn how to multiply, then you learn how to divide, and then we learn about exponents. We learn about powers. Well, let me show you what we've got here. If we are multiplying expressions with the same base, we drop all the way back. It's kind of like 2 steps. We go from multiplying all the way back to adding. If we're dividing, we drop back 2 steps and we subtract the exponents. We'll take a guess at what happens if we're raising a power to a power. So if this pattern holds, what do you think we do when we raise a power to another power? So when we take an exponent and raise it to another exponent. Well, if we keep with this dropping down two levels of operations, we'd come right here. When we raise an expression with exponents to another exponent, we multiply the powers. We multiply those exponents, okay? So, a couple quick things we'll look at here. It says simplify, and there are 2 main ways of doing these, and I'll talk about both of them. This means x squared raised to the 3rd. So one way to do this is to just write out in expanded form literally what this means. This means we're going to use this as a base 3 times. So this is going to be x squared times x squared times x squared. This now becomes a product rule, so we're going to go through and we're going to add the exponents together. So if I've got 2 here and 2 here and 2 here, I have x to the 6th altogether. The short way to do this is just say, hey, if I've got a power raised to another power, I'm going to multiply these exponents together, and I get 2 times 3 is 6. Next one, again, I could write down 2 to the 5th times 2 to the 5th times 2 to the 5th times 2 to the 5th. We've got 4 of those. And then this becomes a product, so we're going to add the exponents. So this would be 2 to the, let's see, 5 plus 5 plus 5 plus 5. That would be 2 to the 20th. And again, that's a gigantic number. We're not going to type that into the calculator. Okay, or we can just do 2 to the 5 times 4 is 20. So we get the answer that way. So let me write this up here, 2 to the x to the 2 times 3. And then this one, again, this would be 4n to the third times 4n to the third times 4n to the third times 4n to the third, and then one more. Gets to be a pain in the butt to write. Now notice, because this is in parentheses, there are 5 4s also. Okay, so if we go through and count those up, this would be 4 to the 5th. And then if we count these up, let's see, 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. So this would be n to the 15th. So I'm going to go ahead and circle that. We could also do it this way. Think of that to the 1. So this would be 4 to the 1 times 5, and then, whoops, n to the 3 times 5. Way quicker to do it this way. This is the power rule. So take a look right here. 1 times 5 is 5. 3 times 5 is 15. There's our answer right there. Now, again, just as a general rule for this assignment and some of the others that might come up, if the number, in other words, if the coefficient is more than, if it's more than or bigger than 15, just leave it in exponential form. And if we plug this number into the calculator, it's gigantic, so don't worry about it. And I'm really not going to worry about that one either, but kind of use that as a general rule. So here's the idea. This is the power rule for exponents. If we have a power raised to another power, so if we have b to the m and then we take that whole thing and we raise it to the n, this is b to the m times n. We multiply those together. So again, this is called the power rule. Yeah, the power rule. And some people will call this the power to a power rule. So we could call it the power rule for exponents, or we could call it the power to a power rule. Now, keep in mind, when written properly, a power raised to a power to another power will always contain parentheses. Parentheses. You're going to see a whole bunch of parentheses on today's assignment because there may be more than one factor in that base, and we want to make sure, I mean, this would just look weird if we did 9 to the 2nd to the 6th. That just looks strange. So we make that look right by putting the 9 squared in parentheses. So that would look weird. So we'll just leave that alone, so we're not going to do that. We've got to have parentheses. So again, if I wanted to, I could write down 9 squared times 9 squared. Just keep writing this, multiplying it by itself repeatedly 6 times. There we go, got them all. So then we could go through and apply the product rule, but it's just way quicker. Don't bother doing that, although that's what it means. This is going to be 9 to the 2 times 6, and if you can just write 9 to the 12th, go ahead and do it. You're done. Let's take a look at this one right here. When they have a coefficient here, you do have to be careful, especially when it's negative. So this is going to be negative 2 raised to the 4th, and this is going to be y to the 3rd raised to the 4th. Now, if you can do this separately, right, like this, or you can do it together and figure out what the answer is, that's totally fine, but you've got to make sure that you get this right. The big thing here is notice that we've got 4 negatives. 4 is an even number, so we have an even number of negative. So this would be 2 to the 4th, and this is going to be y to the 3 times 4, so that would be to the 12th. If you want to write it like that, I'm okay with that. If you want to change this, 2 to the 4th is 16, so 16y to the 12th. Let's go ahead and circle that, and we'll call it good there. On this one, same type of thing. We got to be careful here. Negative 2 to the 7th, y to the 3rd to the 7th. This part is almost easier than the numbers right here. So this is going to be 3 times 7. This is going to be y to the 21st. A negative, let's see, there's 7 negative 2. So 7 negatives, that's an odd, that would be negative. We could write it, 2 to the 7th, okay, and that would be okay. I am going to grab the calculator and plug this in though. Let's see what 2 to the 7th is. So if we did 2 raised to the 7th, let's see if it's a number that we could just write down. It is, it's 128. So we could write down 128y to the 21st. The more important thing is, other than just getting the whole thing right, if you write the coefficient as a number or you write it as an exponential expression, I've got to have the negative there. The important thing is that you understand how this rule operates. There are times where we'll get a number that's small enough to go ahead and write, and I certainly wouldn't want to do this one. That is absolutely huge. Okay, let's take a look at the next one. Here's the first one where we've got two exponents inside and then one on the outside. So again, we could write down what it means at length, but it basically means this. We're going to do x to the third, and that 4 is going to apply to that factor, and that 4 is going to apply to that factor. So it's almost like distributing. So this is going to be x to the 3 times 4 is 12, and this is going to be y to the 2 times 4 is 8. We're going to circle that and we're done. Again, these go very quickly once you get used to these. So we're going to apply the exponent here. That's 6 to the third. We're going to apply the exponent there. That would be m to the 5 times 3 is 15. This is going to be n to the 4 times 3 is 12. You could write the answer that way, but I suspect that 6 to the third, hey, wait a minute, you should have that memorized. I'm hoping some of you have that memorized, so let's do 6 caret 3. Let's think about what that number is, 216. That was one of those perfect cubes. So 216, m to the 15th, n to the 12th. And then over here, take a close look at this, negative 5 squared. And then if you want to write these separately, be my guest. If you want to do it like this, negative 5 squared, 2 negatives and 2 5s would make a 25. If you want to multiply here or here, this is going to be x to the 6th. If you want to multiply here or here, this is going to be y to the 14th. So we'll circle that. Done with that problem. Let's go ahead and apply it here. This is 5 to the 6th, because again, there's a 1 there. This is u to the 6 times 6 is 36. V to the 5 times 6 is 30. So we can write the answer that way. Now, just for the heck of it, I suspect that this is a little bit too big, but let's just check. We're going to raise that to the 6th. Hop outside there, hit enter. Yeah, 15,625, way too big, so let's go ahead and leave it like that. Same thing's going to happen here. This is going to be 6 to the 5th, because again, that was a 1. So it's kind of like distributing. It's not really distributing, but you can think of it that way. So this is going to be j to the, that would be the 30th, because 5 times 6 is 30. K to the 10th, 2 times 5 is 10. N to the 20th. Now you'll notice that all of these exponents on these guys right here, they all end with a 10 because we've multiplied them by a 5 times an even number. So it works out that way. All right, great practice, really good skills to have. Let's make sure we know how to do this. If you've got questions, please ask.